Okay, welcome to 8th grade 11.7 notes. Today we'll talk about slope-intercept form. So I'm a little bit of a time crunch, but we'll try to get through this in kind of a timely manner, and hopefully it helps you on your lesson. I will be back on Wednesday, and if you do have any questions, I can answer them then. So slope-intercept form, essentially what it is it looks like this. Now, you were reminded the other day that n is the slope of a line. What the b is literally the y-intercept. All right? So the y-intercept, what that means is if you were to look at a graph, and everything we're talking about is a linear equation, which is a line, and we drew something in like that, it would have two different things. Number one, it would have a y-intercept, which is known as the b. It would also have a slope. All right, well, we know the slope is the rise over the run. What the x and y stand for is they are any different coordinate on the line. So this is the most basic form of a graph when we take a look at mathematics. It shows lots of different stuff. All right. You could have a starting point, which is always your b, and then you'll have a rate, which is always going to be your slope. All right. So really, b, if we look at it in a real world context, b is going to be that's two b's there. B is going to be your starting point. All right. And then from there, you'll always have a rate. So let's say we started at a certain amount of miles, and then from there we drove a certain miles per hour. Well, that would be the rate. So let's go to our first example. All right. It says find the slope and the y-intercept of the graph of the equation. Okay. So keep in mind we're using that as our equation. All right, so if we take a look at letter A, you really are, all you're doing is matching things up. So the slope, which is your n, well, we always assume there is a 1 in front of the x value. So you don't always need to have a rise over a run. You can simplify the number. So if x is by itself, it's not 0, it's 1. In fact, if it were 0, there would be no x there, since 0 times anything is 0. The second one is your b. Okay, well, what is the y-intercept here? Which again is the b. There's the n. Okay, well, the y-intercept, if I look at the problem, it's -3, and anytime it's a -3, we consider that to be a -3. Okay, so letter B. Now, letter B is not set up for you. You need to make it look like this. So you're going to have to do a few things. You need to first off go ahead and bring everything except for the y value to the right side. If you remember, we did something called function form early on in this chapter. Really, that is essentially the same thing. All right. So first off, if I want to do that, I have to add 4x to both sides of this equation. All right. So this one here would cancel off. Okay. I would then have a 2y left over on the left side. I'm going to leave a little bit of room here. That's why I moved it over. Okay, if you look at the formula, the x comes first. So since it's a positive 4x, I put 4x first. I also put a plus 16 behind it. 16 is not negative somehow. It's positive to start with, therefore it stays positive. To finally finish this problem, we have to divide by 2 to get the y by itself. You have to divide every term by 2, meaning if there is a plus or a minus sign separating two different numbers and variables, they are both considered terms. So you do have to divide those both. So that cancels. You get y equals 2x plus an 8. All right. At that point, you can recognize or you can identify the slope, which is 2. You can also identify the y-intercept. And notice how I am using the letters that they stand for. which is important. So we do have a slope of 2. We also have a b that equals 8, which is our y-intercept. Okay, just another example here. I'm just going to quick do this one. The m here, where the slope is 6, the b is 1. Okay, this one here, it says to graph. All right, so there's 2 steps to graphing. So the first step, okay, is to graph the y-intercept, okay, which is also known as your little b. Okay, so if I do that, all right, I go over to my graph, which you can either do or you can use the graphs given to you on the worksheets. I go ahead and I graph the b. Now, b is literally telling me it is a 3. So I go to the y-axis, I go up to positive 3, and I make my point there. All right, so there I just graphed the y-intercept. Step 2 is use the slope. Okay, in other words, the m is also the rise over the run to find a second coordinate. Okay, which is really pretty easy. So if I look at it, my rise over my run is 1 over 2. Okay, rise is first. So from this coordinate, all right, from the B, I go up 1, and then I will go over run 2. Up 1 over 2 would lead us to this new coordinate. So therefore, I have two points, and that's all you need for a line, all right, is your 2 coordinates. Once you do those 2 things, you can draw your line through, and you'd be done. Okay, what if I have a word problem? It says you are at the base of a trail on Mount Rainier in Washington. The temperature is 50.9 degrees. The temperature changes at a rate of negative 0.005 degrees per foot of elevation. So in other words, if you go up a foot, all right, you're going to lose some temperature, which is pretty normal with a mountain. It says, what is the temperature 1,000 feet above the base? Okay, so it looks like our temperature is going to be dictated by our elevation. So first off, if I think about this in terms of a slope-intercept form equation, first off, our y, which is always your dependent variable, is dependent on our elevation. So my y, I'm going to consider temperature, because I know that is going to be dependent on our elevation, all right? Now, B would be our initial temperature, okay? So in this case, they give it. They give you 50.9 degrees for your initial temperature, all right? Well, if I go ahead and I plug that in, it'd be plus 50.9, all right? Your rate, which it gives you, which is the same thing as your slope, is negative 0.005. And I'm going to put an E there because E would be my elevation. Now that is going to be in feet. Okay, so if you want to figure out what 1,000 feet above the base is, all you have to do at that point is just plug 1,000 in for your E. Okay, well that would be a pretty easy way to figure this out. Now, if you remember from our rules a long, long time ago, this has 3 zeros on it. So that means I could go to my decimal over there, and I could move it 3 spots. So in other words, I could make this -5 plus 50.9. All right, well at that point, you could add those 2 together, and I would get 45.9. All right, so what does that tell me? That tells me at 1,000 feet, the temperature is 45, that is, 45.9 degrees Fahrenheit. Okay, so I do have a few more graphs here. Unfortunately, I'm not going to have time to go over those. Please do your best on the worksheet. Like I said, I don't have the time to do any more than I do right now, but at least this will give you a start on it. We definitely can go through any questions when I come back on Wednesday.